Homework 33 starts off with solving a triangle with a law of sines. We use the law of sines in a couple different cases, but on this first one, if you have two angles and a side, angle, angle, side. The law of sines says if you take the sine of angle A over side A, it's equal to the sine of angle B over side B, which is equal to the sine of angle C over side C. And so in this case it says consider the triangle ABC like the one below. Suppose that angle B is 25 degrees, angle C is 106 degrees, and side A is 7. So first thing we're going to do is figure out what the measure of angle A is. Hopefully you know that all three angles in your triangle add up to 180 degrees. So if we take 180 degrees, we subtract off our other two angles, 25 and 106. We're going to come up with how many degrees angle A is. So 180 minus 25 minus 106 gives me 49. So angle A is 49 degrees, and so that's going to be one of the things that you are going to enter in as part of your answer is what's the measure of angle A? 49 degrees. Now we can use the law of sines in order to find our other two sides. We have angle A and side A. So we can say the sine of 49 over 7 equals, and then I'm going to do B, so the sine of 25 over side B. We're going to solve this by cross multiplying, so doing it the long way, I would have B sine of 49 equals 7 sine of 25. I end up dividing by the sine of 49. So this is my calculation right here. These are in degrees, so make sure your calculator is in degree mode. We were in radians the other day, so make sure you just switch it back to degrees. Mode, and then you have the degree radians and gradients, so we want mode 1, which is degrees. You should see the little D up on your calculator to make sure you're in degrees. So I'm going to calculate what is 7 sine of 25 divided by the sine of 49. 7 sine of 25 divided by the sine of 49 gives me 3.9198, so forth and so on. I want to round my answers to the nearest tenth, and so 3.9 would be my answer for side B. Then I have to find side C the same kind of way. I want to use the one that I didn't do any rounding on, so I'm still going to use the sine of 49 over 7. But this time I'm going to use angle C, so I'm going to use the sine of 106 over C. So again, if I would go through the process of cross multiplying, I'm going to take the 7 times the sine of 106. I'm going to end up dividing by the sine of 49. If you need to, do it the long way and end up dividing, but just to save myself some space, I'm going to take a little shortcut there. So C is going to equal 7 times the sine of 106 divided by the sine of 49, and then I'm going to use my calculator. So 7 sine of 106 divided by sine of 49 gives me 8.915, again rounding off to the nearest tenth. C is going to be 8.9. And now I found angle A, side B, and side C. Number 2 then, if I look at my triangle, suppose that angle A is 115 degrees, angle C is 37 degrees, and side A is 11. Again, we're going to find B by taking 180 minus our 115 minus our 37. 180 minus 115 minus 37 gives us 28. So angle B is going to be 28 degrees. So looking at our law of sines then, we want an angle that has opposite my side measure. Again, this happens to be A because I have angle A and side A both. And so I'm going to use that one. So I'm going to say the sine of angle A, which is 115, over side A, which is 11, equals the sine of 28 in order to find side B. Again, I would cross multiply to solve that. So I'm going to take the 11 times the sine of 28. I'm going to end up dividing by the sine of 115, and that's going to give me my answer for B. So 11 sine of 28 divided by the sine of 115 gives me 5.698. I am rounding to the nearest tenth, so 5.7 is what's going to be the side length for B. C, same kind of thing. I'm going to use the one with the given information, the sine of 115 over 11. This time I'm going to use the sine of C, so the sine of 37 over C. Cross multiplying, I would get 11 times the sine of 37. I would end up dividing by the sine of 115. So 11 sine of 37 divided by the sine of 115 gives me 7.304. So rounding off to the nearest tenth, C is going to be 7.3. Number 3, again, we're using the law of sines. It says, consider the triangle like the one below. Suppose that angle A is 58, angle C is 38, and side C is 53. So again, to find angle B, we're just going to take 180 and subtract the 58 and the 38 that we already know. So 180 minus 58 minus 38 gives me 84. So we know that B is 84 degrees. Now on this one, notice that we have angle C and side C. So that's going to be our starting ratio that we want to use. The sine of 38 over 53 is going to equal the sine of, and I'll just do A, so 58 over A. Again, we have to cross multiply, so 53 times the sine of 58, and we end up dividing by the sine of 38 to get our answer for A. So 53 sine of 58 divided by the sine of 38 gives me 73.005. Rounding to the nearest tenth then, A is going to be 73.0. They will have you show it to the 10th spot, and so we do want to put the 0.0 just to specify that, yep, we knew it was supposed to be a 0.0. Then we're going to do B, so we would still use the 38 sine of 38 over 53. That is going to equal the sine of B, which is 84 over B. My 84 doesn't want to show up there because it says page 2. So, cross multiplying, we're going to have 53 times the sine of 84, and then we're going to end up dividing it by the sine of 38. So 53 sine of 84 divided by the sine of 38 gives me 85.614, so 85.6 would be my answer for how long is side B. And now I found my missing information for my triangle. So law of sines, the sine of the angle over the opposite side equals the sine of my angle over the opposite side equals the sine of my angle over the opposite side. Number 4, we're solving a triangle using that law of sines that we had before that said sine of A over A equals sine of angle B over B equals sine of angle C over C. However, in this case, we are going to have ones where we have two sides and an angle, side-side angle. And when we have a situation like that, we could just have one triangle that works, we might have two triangles that work, or we might have no triangles that work. So before I go about doing all my solving, we need a few notes about how do I figure out, do I have one triangle, no triangles, or two triangles? So, first thing they're going to have you do is find what they call H. H is equal to the side adjacent to the angle, which is next to the angle, times the sine of your angle. So, in this case, I'm going to look at this triangle here and say, okay, I have side A is 29, side C is 11, and my angle that I have is 66. So, the side adjacent to my angle is 11, then I'm going to take it times the sine of my angle. So, H is going to equal 11 times the sine of 66. Again, I want to make sure my calculator is in degree mode, but if I do that, 11 times the sine of 66 gives me 10.049. So now what I'm going to do to check is I'm going to say, okay, if H is equal to the opposite side, or the opposite side is greater than my adjacent side, I'm going to have one triangle. So in this case, H isn't equal to the opposite side. It's not 29. Is my opposite side greater than my adjacent side? Well, my opposite side is 29. It is greater than my adjacent side. So on this one, I'm going to only end up with one triangle. I'm going to put my little note there. Now, that one fit the first situation. We were good, but I'm going to finish my notes here about how many triangles I have. So, one triangle if H equals the opposite side, or if the opposite side is greater than my adjacent side, which in this case it was. If my opposite side is less than my adjacent side, and H is greater than my opposite side. So if my opposite is less than my adjacent and H is greater than the opposite, then we're going to have no triangles. If my opposite side is greater than my adjacent side and H is less than the opposite side, which is less than the adjacent side, then I end up having two triangles that work. So, take a minute, jot down those notes, because you're going to need to find out how many triangles you're going to have. 1, 2, 3, 4, no. 0, 1, or 2 are your only choices. So in this case, we've already figured it out. H was not equal to the opposite side, but the opposite side is greater than the adjacent side. We're going to have only one set of answers. So, we're going to use our law of sines in order to figure this out, or at least start with that. We know that if we take the sine of 66 over A, 29, so sine of angle A over side A, it's going to equal the sine of C over 11, since I have side C. Cross multiplying here, this would be times this to get the C by itself, and so I'm going to say 11 sine of 66 over 29 equals the sine of C, and so on our calculator we're going to do the inverse sine. the inverse sine of 11 sine of 66 over 29. You may or may not need the parentheses depending on your calculator. I like to put the parentheses there just in case because it doesn't hurt and I know it's going to work out better that way. So, inverse sine, you're going to use shift sine. You should see sine to the negative 1. In parentheses, I'm going to do 11 sine of 66. And you can just use divided instead of the fraction, or you can use the fraction. I'm going to use divided. So 11 sine of 66 divided by 29, close my parentheses, hit equals. I get 20.27444. I am rounding my answers again to the nearest tenth. So, angle C is going to be 20.3 degrees because I'm going to round that off to the nearest tenth. So, C is going to be 20.3 degrees. Now, we have angle A, we have angle C. Easy enough to find angle B because for angle B we just have to subtract. For angle B, we're going to take 180 minus our 66 minus our 20.3. So, 180 minus 66 minus 20.3 gives me 93.7. So, B is 93.7 degrees. So, we have angles A, B, and C. We have side A and C. We still need side B. Again, to avoid rounding issues, use the original information you had. So in this case, I'm going to use the sine of 66 over 29 equals the sine, and angle B was 93.7 over B then. Solving that by cross multiplying, I'm going to take the 29 times the sine of 93.7. I'm going to end up dividing by the sine of 66, like I did on problems 1, 2, and 3. And I'm going to punch that into my calculator. So 29 sine of 93.7 divided by the sine of 66 gives me 31.678. Again, I'm rounding to the nearest tenth, so side B is going to be 31.7. Now I have all of my angles and all of my sides of my triangle found. Again, I'm not going to write this part down every time. Make sure you have those in your notes because you're going to want to check and find out do you have one triangle, no triangle, or two triangles? So I'm going to keep my paper with my note handy. So, on this one, we know that B is 35, A is 64, and angle B is 109. First thing we're going to do is figure out what H is. So we said to find H, we're going to take the side adjacent to my angle, which is going to be the 64, times the sine of my angle 109. So, 64 sine of 109 gives me 60.513. So we checked with our rules. It said, is H equal to my opposite side? This time my opposite, the opposite of my angle is 35. Well, H is not equal to 35. So then we said, okay, is the opposite side greater than the adjacent side? Well, the opposite side is 35 and the adjacent side is 64. So no, the opposite is not greater than that one. So I know that I don't have one triangle. So I go down to the next one. Is the opposite side less than the adjacent? Yes, 35 is less than 64. And is H greater than the opposite? So H is 60.513. Is that greater than the opposite side of 35? Yes. So, we got that the opposite side was less than the adjacent side. H is greater than the opposite side. We're going to end up with no triangles, so we are going to say no solution. Hey, that was a quick one because it followed the test. If I follow my test, I'm not going to have any triangles that work, so I have no solution. So, number 6, same kind of thing. I'm going to start by finding H. First, I better label my triangle so I know what I have. Consider the triangle ABC. Suppose that side B is 30, side A is 35, angle B is 34. So the adjacent side is 35 times the sine of 34 would give me H. The adjacent side times the sine of my angle. So 35 times the sine of 34 gives me 19.57. So now we check. Is H equal to the opposite side? The opposite side is 30. Well, nope, it's not equal to that. Is the opposite side greater than the adjacent side? My opposite side is 30, my adjacent is 35, so no. The opposite side is not greater than the adjacent side, so we know we don't have one triangle. So we check the next part. Is the opposite side less than the adjacent side? Yes. The opposite is less than the adjacent. Is H greater than the opposite? No, H is not greater than the opposite. 19 is not greater than 30. So we know we don't have 0 triangles, which probably means we have 2 triangles, but we'll look at our test. Is the opposite side greater than the adjacent side? The opposite side I think I wrote that down wrong. Is the opposite side should be less than the adjacent side. So is my opposite side less than the adjacent side? Yes, 30 is less than 35. And is H less than the opposite side, which is less than the adjacent side? So H is 19.57. Is that less than 30, which is less than 35? Yes. So we have 2 triangles. So fix your notes because I think I wrote that down wrong. At least I wrote it down wrong on my paper. I should have said, is the opposite side less than the adjacent side? And H is less than the opposite, which is less than the adjacent. Then you get 2 triangles. So go back, fix that on your notes. I better fix it on my notes. All right, so in this case, H is less than the opposite, which is less than the adjacent. I'm going to end up with 2 sets of answers. Hopefully I left myself enough room to write. So, starting this one off, we are going to use our law of sines. Finding my pen here. I have angle B and side B. So I'm going to use the sine of 34 over 30 equals, and I have side A. So I'm going to use the sine of A over the 35. I'm going to solve that. So cross multiplying. Since this is under here, I'm going to take 35 times the sine of 34 and divide it by 30. That's equal to the sine of A. And so in order to figure that out, we have to do the inverse sine of our 35 sine of 34 over 30. So inverse sine parentheses 35 times the sine of 34 divided by 30, close my parentheses, gives me 40.722. So rounding that off, I would have 40.7. So A is going to equal 40.7 degrees. Now that's for one of my triangles if A is an acute angle. If A happens to be the obtuse angle, what I'm going to do for my other angle A is to take 180 and subtract the 40.7. If it's obtuse instead of acute, making a straight line across here, I would take 180 minus 40.7. So 180 minus 40.7 gives me 139.3. So I'm going to have a second set of answers. 139.3 is going to be my other answer for angle A, because I'm going to have two different triangles. So from there, I knew that this is 34, this is either 40.7 or 139.3, so I can find angle C by subtracting. So both of these I'm going to find angle C. The first one I'm going to take 180 minus my 34 and minus my 40.7. So 180 minus 34 minus 40.7 gives me 105.3. So here angle C would have to be 105.3. If angle A was my obtuse angle, I would take 180 minus my 34 minus my 139.3, using 139.3 for angle A. So 180 minus 34 minus 139.3 gives me 6.7. So if angle A is my obtuse angle, then angle C will be my acute angle. And so either angle A is 40.7 degrees, which leaves angle C being 105.3 degrees, or angle A is 139.3 and angle C is 6.7 degrees. Now, we found side A, or angle A and angle C. We still have to find side C. So in order to find side C, we're going to use the law of sines on both of these two things. So the given one was the sine of 34 over 30. Sine of 34 over 30 is going to equal side C, which would be the sine of 105.3 over C. So solving that one, when I cross multiply, I'm going to take 30 sine of 105.3 divided by the sine of 34. 30 sine of 105.3 divided by, whoops, that looks weird, 30 sine of 105.3 divided by the sine of 34 gives me 51.747. Why that didn't come out right. I came up with a rounding error. The reason I got a rounding error is because I used the rounded off angle here. If I would read my directions, it says to carry your intermediate computations to 4 decimal places, so that when you're doing your calculation, instead of using the rounded off answers up here, I have to use my answer, and I should have carried it to 4 decimal places. So that should have been 40.7. There was another 2 on the end of that. So I have to make sure here I use the 40.7 222. So now I got to resubtract here. So for angle C, I'm going to have 180 minus 34 minus 40.7222. And so this would have been 105.2778, carrying it to 4 decimal places. So when I did my problem over here, I should have used 105.2778. instead of using the 105.3. So now if I recalculate that using the 0.2778, 30 times the sine of 105.2778 divided by the sine of 34. Now I'm getting 51.752. And so when I round that off to the nearest 10th, I get 51.8. So a good lesson to be learned there is when it tells you to carry your computations to 4 decimal places, make sure you do that when you're doing your work, because if I use my rounded off answer, even though that's what the answer is I'm going to enter in, I get a little bit of rounding issues. And so I would have put in 51.7. It would have said I was wrong because it really should have been 51.8 because of the rounding. So we still need to find C over here. The same kind of thing holds true. Here, trying to figure, oh, there we go. When I did this one, I should have carried this out. And so I would have had 180 minus 40.722, which means I would have used 139.2778. So over here, I would have used 139.2778. And so 180 minus 34 minus 139.2778 gives me 6.7222. So when I do my law of sines, like I did over here, I'm going to use the 6.7222 and make sure I carry it to 4 decimal places. So again, my law of sines, I'm going to take my sine of 34 over 30 equals the sine of 6.7222 over C. So when we solve that, we would take 30 times the sine of 6.7222 divided by the sine of 34. So 30, excuse me, times the sine of 6.7222 divided by the sine of 34 gives me 6.279. 6.279 rounds off to 6.3. So I am going to enter in my answer with 2 sets of answers. Either angle A is 40, which makes angle C 105.3 and side C 51.8, or angle A is 139.3, angle C is 6.7, and C is 6.3. So, moral of the story here is carry your computations out to 4 decimal places, because when you're doing this last part where you're using the law of sines, your angles can't be rounded off too far, or you may get incorrect answers due to rounding. All right, 7, 8, and 9, word problem using the law of sines. Again, the law of sines says if I take the sine of A over side A, it's equal to the sine of B over side B equals the sine of C over side C. So Tom and Kayla are standing on a riverbank 240 meters apart. They labeled that for us at points A and B respectively. See the figure below. They want to know the distance from Tom to a house located across the river at point C. So Tom is over here. We want to find this side right here. Tom measured angle A to be 45 degrees, which they've got written there. Kayla measures angle B to be 66 degrees. We want to find the distance from Tom to the house. Round your answer to the nearest tenth of a meter. So, in order to use our law of sines, since we know this side here, we need to know this angle down here. And since we know in our, excuse me, in our triangle that all 3 angles add up to 180, C is going to equal 180 minus 45 minus 66. I'm going to grab my calculator. 180 minus 45 minus 66 is 69. So, this angle down here is 69 degrees. We can now set up our law of sines. So, the sine of 69 over the 240 is going to equal, since we want this side here, we're going to use the sine of 66 over our x. Solving that, we would cross multiply, so we would have x sine of 69 equals 240 sine of 66, and of course then we have to divide this by the sine of 69. So, again, be sure your calculator is in degree mode. If it's not, mode number 1 would put it into degrees. So we have 240 sine of 66 divided by the sine of 69, and I get 234.8495. I want to round that off to the nearest tenth, so 234.8, and this would be in meters. So Tom is 234.8 meters from the house. Number 8, going to be the same kind of thing. Mountain officials want to know the length of a new ski lift from A to C. So from A to C would be the side right over here. Whoops. My board is randomly writing for me again. They measure angle DAC. DAC, this angle down here to be 33. They then move 1,220 feet to point B. So from A to B was 1,220. Measured angle DBC. DBC is this angle here, which is 22. What is the length of the new ski lift from A to C? So again, I need to know what this angle up here is, but first I need to find this angle down here. Since this is going to be 180 degrees, I'm going to take 180 minus 33. So 180 minus 33 gives me 147 for that angle in there. So I know this one's 22, this is 147. To find this one up here, again, I'm going to subtract from 180. So 180 minus 147 minus 22. 180 minus 147 minus 22 gives me 11. So this angle up here is going to be 11 degrees. So now I can use my law of sines because I have the angle and the opposite side. So the sine of 11 over 1,220 is going to equal, I want this side, so the opposite angle is 22, the sine of 22 over x. Solving that again, if I take a little shortcut, I'm going to take this times this, so 1,220 sine of 22, I'm going to end up dividing by the sine of 11. If you need to cross multiply and solve it, go ahead, but I'm just saving myself some writing room. This times this, and I end up dividing by that. So 1,220 times the sine of 22 divided by the sine of 11 gives me 2395.170328. I am rounding to the nearest tenth, so 2,395 point, I'd have to round that up to 2, and this is in feet. So the ski lift is 2,395.2 feet from point A. Number 9. A tree that is 61 feet tall is growing at an angle of 82 degrees. With respect to the ground, see the figure below. Rob, who is standing a certain distance away from the base of the tree, finds that the angle of elevation from the ground to the top of the tree is 36 degrees. How far is he from the base of the tree? So we want to find this side right here. Although they didn't draw the line right here, here's my line for my triangle. There's my 61 feet. And so again, I need to know this angle up here on the top. So 180 minus 82 minus 36. 180 minus 82 minus 36 gives me 62. So 62 degrees is how big that angle is up there. So I'm going to use the 61 with the 36, so sine of 36 over the 61, and then I want the x, so I have to use the 62, sine of 62 over x. So the angle with the opposite side, the angle with the opposite side, and again when I solve that by cross multiplying, I'm going to take the 61 times the sine of 62. I'm going to end up dividing by the sine of 36. So 61 sine of 62 divided by the sine of 36 gives me 91.6317, rounding to the nearest tenth again, 91.6 feet would be how far it is from this person to the base of the tree. So law of sines, when I have two angles and a side, the law of sines is probably the easiest one to use to find the missing information from your triangle. Angle, two angles and a side. All right, 10, 11, and 12, we are doing the law of cosines. The law of cosines is used when you have the case where you have a side, side, side. You have all three sides, but none of the angles. So the law of cosines says, if I take a squared, it's going to equal b squared plus c squared minus 2bc times the cosine of angle A. Now they're going to rearrange it and solve it for all the rest of the variables, but notice here when this was a squared, that this was b and c, this was also b and c, and then whatever this was, that's the angle that we have over here. So when I do it for b squared is going to equal a squared plus c squared minus 2ac cosine of b. And if I have for c squared equals a squared plus b squared minus 2ab cosine of c. So my law of cosines, when I have side, side, side. So for this one says, consider the triangle ABC like the one below. Suppose that A is 35, B is 49, and C is 40. Solve my triangle. In other words, find what angle A is, angle B is, and angle C is. Carry your intermediate computations to at least 4 decimal places. Round your answer to the nearest tenth. So if we learned a lesson from the other day, make sure you carry out your decimal far enough so you don't get a rounding error on your answer. So I'm plugging this in. First of all, I'm going to find angle A, so I'm going to use my top one here. A squared equals b squared plus c squared minus 2bc cosine of A. So a squared, 35 squared, equals b squared, 49 squared, plus c squared, 40 squared, minus 2bc, so 49 times 40, cosine of A. So this was side A, cosine of A over here. Now when I solve this, I'm going to go ahead and move these two things over here and use my calculator. So first of all, I'm going to say 35 squared minus 49 squared minus 40 squared, moving this and this, is equal to negative 2 times 49 times 40 cosine of A. Now I'm just going to grab my calculator and do my calculations. So 35 squared minus 49 squared minus 40 squared excuse me, is negative 2,776. Over here, negative 2 times 49 times 40 gives me negative 3,920 cosine of A. So when I divide, I'm going to have a negative over a negative. So 2,776 over 3,920 equals the cosine of A. So in order to solve that on my calculator, I end up doing the inverse cosine of that fraction, 2,776 over 3,920. So on my calculator, shift cosine in parentheses 2,776. I can either use the fraction button or the division. I'm just going to use the division. So 2,776 divided by 3,920, close my parentheses, hit equals, I get 44.9143. I want to round my answer to the nearest tenth. So for angle A, I have 44.9 degrees. Angle A, 44.9 degrees. Now, I still need to find angle B. So for angle B, now I'm going to use my second formula. So B would be 49 squared equals 35 squared plus 40 squared minus 2 times 35 times 40 cosine of B. So when I solve this, taking a few more shortcuts so I have writing room, I'm first of all going to move these over to the other side. So 49 squared minus 35 squared minus 40 squared, I'm going to end up dividing by this. So divided by negative 2 times 35 times 40 is going to equal the cosine of B. I'm still going to figure out the top and bottom separately. Otherwise, I might have to use parentheses around the bottom, but I'm just going to do them separately. So 49 squared minus 35 squared minus 40 squared would give me negative 424. Negative 2 times 35 times 40 gives me negative 2,800. A negative over a negative is going to make that a positive. So I'm going to do the inverse cosine of 424 over 2,800. So punching that into my calculator. Shift cosine parentheses 424 divided by 2,800, close my parentheses, gives me 81.29. So 81.2902, I would round that off to 89.3. So B, 89.3 degrees. Now, the next part is, I could use the third one with the law of cosines and figure out angle C, but because I know what angle A is and what angle B is, I can take a shortcut to find angle C. In order to find angle C, I can just subtract from 180 degrees. However, be careful. Try not to use the rounded off values, and so use these ones before you round it off. So I'm going to go ahead and take 180 minus my 44.9143 minus my 81.2902, just so I don't get rounding errors on my final answer. So 180 minus 44.9143 minus 81.2902 gives me 53.7955. So if I round that off, 53.8 degrees. And so, after all of that work, if you can read all of that, angle A was 44.9, angle B 89.3, C 53.8. Again, it doesn't happen a lot where you get a rounding error, but just to be careful, try not to use your rounded off angles. Use the ones before you rounded your answer, just to make sure that you get the right decimal place on your answer. So, that was 10. We need to go to 11. Number 11, same thing. I'm going to use my law of cosines. Consider my triangle. A is 24, B is 38, C is 123 degrees. Now in this case, I've got two sides and an angle. Side, side angle. Two sides in the included angle, so I should probably write it this way. Side, angle, side is probably how they have that. Side, angle, side case. Again, I'm going to use my law of cosines eventually in here, and I might even use my law of sines while I'm at it. So, on here, if I'm going to solve that first one here, I want to find my missing side, which is side C. So I can use my law of cosines and say that C squared is equal to A squared plus B squared minus 2AB cosine of C, which is 123 degrees. Now I could probably do that whole calculation at once, but I'm going to kind of put it together. So I'm going to do these two things first. 24 squared plus 38 squared is 2020 minus 2 times 24 times 38 minus 1824 cosine of 123. I'm just going to punch that in. So 2020 minus 1824 cosine of 123 gives me C squared equals 3013.4216. To solve that, since it's C squared, I would have to take the square root. So I'm going to do on my calculator square root of the answer. Then I don't have to type it back in. Answer is right next to the equal. So square root ANS for answer. And I would get 54.8946. I'm rounding to the nearest tenth, so I would say 54.9. So side C we got was 54.9. We still need to find angle A and angle B. Now we could use the law of cosines to find angle A and angle B, but we can also use the law of sines to find angle A and angle B. And so in this case, I'm going to, since we're practicing the law of cosines, I'm just going to use my law of cosines. So I want to find side or angle A. So if I'm going to find angle A, I'm going to use side A. So I'm going to say 24 squared equals B squared, 38 squared plus C squared. Now be careful on this one again. We don't want to round that number off, so make sure you use the 54.8946 squared minus 2 times 38 times our 54.8946 sine of A, smooshing that all in there. So again, your intermediate computation should be to at least 4 decimal places. If you round them off, you may get rounding errors, so try not to do that. And so again, when I solve that, I'm going to take 24 squared minus 38 squared minus my 54.8946 squared. And I'm going to divide that by negative 2 times 38 times 54.8946. So on the top of my fraction, 24 squared minus 38 squared minus 54.8946 squared gives me negative 3881.4 171. On the bottom, negative 2 times 38 times 54.8946 gives me negative 4171.9896. Again, I have a negative over a negative, so I'm going to use a positive, and I'm going to do the inverse cosine then of 3881.4171 over 4171.9896. Negative over a negative was a positive. So inverse cosine parentheses 3881.4171 divided by 4171.9896 equals 215,103. So angle A is going to be 21.5 degrees. Angle B. Angle B is going to be the easier one to find because I know angle C and I know angle A. I can take 180, subtract my 123, subtract my 21.5103, again to avoid rounding errors. So 180 minus 123 minus 21.5103 gives me 35.4897. So angle B is going to be 35.5 degrees. So I found side C using my law of cosines. I found angle A using my law of cosines. I found angle B by taking 180 and subtracting angle A and angle C, which I already knew. One more of those. Number 12. Again, this one is a side, side, side case. We know 3 of the sides. Side, side, side. A is 64, B is 61, C is 15. So using our law of cosines, again, I always like to just start with A. So 64 squared equals 61 squared plus 15 squared minus 2 times 61 times 15 cosine of A. So solving that or rearranging it, 64 squared minus 61 squared minus 15 squared divided by negative 2 times 61 times 15 equals the cosine of A. Simplifying the top, 64 squared minus 61 squared minus 15 squared would give me 150. It was positive that time. And negative 2 times 61 times 15 gives me negative 1830. So the inverse cosine of negative 150 over 1830, since we had a positive over a negative. So inverse cosine parentheses negative 150 divided by 1830. Close my parentheses, hit equals, I get 94.7016. So this is angle A. Angle A is going to be 94.7 degrees then. Now you may wonder, do I need to round that last number off? Just carry it to 4 decimal places. It really shouldn't make any difference if you would have rounded that up to 7 because we've carried it far enough. So I just write down the first 4 decimal places. I don't worry about rounding that end number. You can, it shouldn't make any difference. I found angle A. Next I need to find angle B. So again I'm going to use my law of cosines. B, 61 squared equals A squared plus C squared minus 2 times A times C cosine of B then. So same kind of thing, rearranging 61 squared minus 64 squared minus 15 squared over negative 2 times 64 times 15. So 61 squared minus 64 squared minus 15 squared is negative 600. Negative 2 times 64 times 15, negative 1920. So we're going to do the inverse cosine of, I have a negative over a negative, so a positive 600 over 1920. So shift cosine, inverse cosine, parentheses, 600 divided by 1920, close my parentheses, gives me 71.7900. So that's going to round up to 71.8. Angle C then, since I know angle A and B, I can just subtract from 180. So 180 minus my 94.7016 minus my 71.9700. So 180 minus 94.7016 minus 71.9700 gives me 13.3284. So angle C is 13.3 degrees when I round that off to the nearest 10. Oops, wait a minute here. I can't read my own writing. That was not supposed to be 71.97. It was supposed to be 71.79. Now let me resubtract that. So 180 minus 94.7016 minus 71.7900. 180 minus 94.7016 minus 71.7900 gives me 13.5084. So 13.5 should be my correct answer there. Trying to switch numbers around on you. So angle A came out to be 94.7, B 71.8, and C 13.5. I don't like my 8 there either. All right, so use the law of cosine to find angle A, the law of cosine to find angle B, and then took 180 and subtracted angle A and angle B to find angle C. We are going to do a word problem using the law of cosines. We said when we had the case where we had side, angle, side, that we could use the law of cosines in order to solve our problem. So we're missing this side here that's across from our angle. Sam wants to know the length of a tunnel built through a mountain. To do so, he makes the measurements shown in the figure below. Use these measurements to find the length of the tunnel. So I have side, angle, side. I'm going to find this side right here. So I'm going to say x squared is going to equal, and it doesn't matter which is which, but I'm going to have 230 squared plus 173 squared minus 2 times 230 times 173 times the cosine of the angle that's across from x, which is 75. So solving that, again, I'm going to put these two together first. So 230 squared plus 173 squared would give me 82,829 minus 2 times 230 times 173 gives me minus 79,580 cosine of 75. Now here you can't subtract that first because this is times this. So punch it all in at once then. 82829 minus 79580 cosine of 75 gives me So that x squared is equal to 62,232.1803. Again, there's a 9 on the end. I'm not really worried about rounding it off. And in fact, I'm not even going to clear my calculator. I'm going to do the square root of my answer. So square root, A and S button to do square root of my answer. It equals x equals 249.4637. So rounding to the nearest tenth, 249.5. We are in meters. So what is the length of my tunnel? 249.5 meters. So law of cosine, when we have side angle side case there, we can find our missing side. Here's one where we have all three sides. So we have the side, side, side case. We said when we had side, 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 we'd use the law of cosines. Two airplanes leave an airport at the same time. An hour later, the planes are 228 kilometers apart. If one plane has traveled 288 kilometers, the other one 283 kilometers, find the angle between their flight paths. So I'm finding the angle that's opposite the 228. So when I'm doing my law of cosines, 228 squared is going to equal 283 squared plus 288 squared minus 2 times 283 times 288 times the cosine of the angle opposite of that, which is theta. So when I solve this like I did before, I'm going to have 228 squared minus 283 squared minus 288 squared over negative 2 times 283 times 288. That's going to equal the cosine of my angle. So simplifying the top, 228 squared minus 283 squared minus 288 squared gives me negative 111,049. On the bottom, negative 2 times 283 times 288 gives me negative 163,008. So I am going to do the inverse cosine. Since this is a negative over a negative, again I can make it positive. 111,049 over 163,008. So, shift cosine parentheses. 111,049 divided by 163,008. Close my parentheses, hit equals. I get 47.0586. Rounding to the nearest tenth would be 47.1 degrees. So that is the measure of this angle right here, 47.1 degrees. One more of those using my law of cosines. Randy is on vacation at a tropical bay which has 3 islands. He rents a boat on island A and plans to travel to navigate to island C, which is 13 miles away. Based on the figure below, at what angle theta should he navigate to go to island C? So, again, we have the side, side, side case. We have 3 of the sides. We're looking for the angle. We're looking for the angle that's opposite the 10 miles. So putting that into my law of cosine, 10 squared equals 13 squared plus 15 squared minus 2 times 13 times 15 cosine of theta. And rearranging to solve that. 10 squared minus 13 squared minus 15 squared divided by negative 2 times 13 times 15 is going to equal the cosine of theta. So figuring out my top number. 10 squared minus 13 squared minus 15 squared gives me negative 294. On the bottom, negative 2 times 13 times 15 gives me negative 390. We're going to do the inverse cosine. This is a negative over a negative, so of 294 over 390. Oh, a second. So if I do inverse cosine parentheses 294 divided by 390, I get 41.0753. So rounding that off, I would have 41.1 degrees for my measure for angle A. All right, so law of cosine. Either when you have side, angle, side, or side, 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 we can use the law of cosines to find our missing parts. 16, 17, and 18, finding the area of a triangle using trigonometry. First of all, if you remember back from geometry class, to find the area of a triangle, the area is half the base times the height. So we want to draw the height into our triangle. When we draw in the height, we want to draw it opposite the angle that they have marked. So it's going to go from here, forming a right angle with the base. And so now I have my right triangle in there, and I need to find what my height is. So what I'm going to use is I'm going to use that the sine of my angle is equal to the opposite over the hypotenuse. The side opposite here is actually going to be my height. This side here is my hypotenuse, right? So opposite over the hypotenuse. So I would say that the sine of 39 degrees is going to equal the opposite side, which is h, over my hypotenuse, which is 5. So solving that, 5 times the sine of 39 is going to equal h. I'm just going to leave it like that. I'm not going to calculate it yet. I'm just going to throw it into my formula for area. So area is equal to 1/2 times the base. The base is the one that we drew our right angle to, so that would be our 8, times our height, which we found up here, 5 sine of 39. And then I'm going to grab my calculator and just punch that in. So 1/2, you can either use 1/2 or 0.5 times 8 times 5 sine of 39 gives me 12.5864. We want to round to the nearest hundredth, so we would say 12.59. I'm in meters. Since I'm doing area, I would then have meters squared. So 12.59 meters squared is going to be your answer. If we look at 17, once I can get to 17, it says find the area of the triangle. So on this one, if I want to draw my height in here, I'm going to draw my height, but I'm not going to be able to draw it to make a right angle here. If I was going to draw it to make my right angle with my base, I would have to draw it over here. If I drew straight. There we go. That looks closer to a right angle. So when I'm looking at this, the height of my triangle is this side here. I need to know this angle here. This is 136, so if I took 180 minus 136, I would get 44, so that angle there would be 44. So if I'm going to try to find out what my height is, again, I'm going to say that I have the opposite side over the hypotenuse, and the hypotenuse is always opposite your right angle. So I'm going to say that I'm going to do the sine of 44 equals the opposite side, which is h, over my hypotenuse, which is 14. Crazy thing is, if you do the sine of 44 or the sine of 136, you actually get the same number, but that's how this one is going to work because I have this obtuse angle. In order to get my right angle drawn down to my side, that's my base, I have to draw it out here, and so I use the 44 instead. So solving this, again, I'm just going to do 14 sine of 44 equals h. So formula for area, 1/2 times my base. My base is actually this 9. That's the side I would have drawn my right angle down to, so that's my base. Times my height, 14 sine of 44. And so using my calculator here, 0.5 times 9 times 14 sine of 44 gives me 43.7634. I want to round my answer off to the nearest hundredth, so 43.76. I am in meters again, so meters squared since I'm doing area. Number 18. This one's going to be a little bit easier to draw since I have an acute angle instead of an obtuse one. If I draw my height in there, drawing it down to my base, if I can draw a right angle in there, looks something like that. So this is going to be my height. So I'm going to say that the sine of 50 equals the opposite side, which is h, over my adjacent side, or my hypotenuse, my opposite side over my hypotenuse, which is the 6. And so I would say 6 sine of 50 equals h. So here's my opposite. Here's my hypotenuse, since it's opposite of my right angle. Sine is opposite over hypotenuse. Formula for area, 1/2 times the base. The base here is 7, times my height, 6 sine of 50. So 0.5 times 7 times 6 sine of 50 gives me 16.0869. Rounding that off to the nearest hundredth then, I'd have to go with 16.09. I'm in feet, so feet squared would be my label. So 16.09 feet squared would be the area of that triangle. And the last three, 19, 20, and 21, are using Heron's formula. Heron's formula is another way to find the area of a triangle if you have all three sides. So what's the first thing they do is they find what they call the semi-perimeter. Well, to find the perimeter, you just take A plus B plus C. Semi means half. And so for the semi-perimeter, we're going to do half of A plus B plus C. They're going to call that S. Then they're going to use the formula that in order to find the area of my triangle, I'm going to do the square root of S times S minus A times S minus B times S minus C. So, using those two formulas, first of all, to find my semi-perimeter, I'm going to do half of 12 plus 14 plus 15. So, 12 plus 14 plus 15 is 41. Divide that by 2, I get 20.5. Putting that into the formula for area, I would do the square root of 20.5 times 20.5 minus 12 times 20.5 minus 14 times 20.5 minus 15. I'm just going to use my calculator and do all of that together just like it looks with the parentheses. So I'm going to start with 20.5 parenthesis, 20.5 minus 12 parenthesis, parenthesis on the other side, 20.5 minus 14 parenthesis, and then parentheses again, 20.5 minus 15 parentheses. If I hit equals, I get the square root of 6229.4375. 6,229.4375. Now, on my calculator again, I have that button that says ANS for the answer. So I'm just going to do square root, ANS, square root of the answer, or you could type that number in under your square root. Hit equals, I get 78.92678, rounding to the nearest tenth on this one, so I'm going to say 78.9. Again, I was finding area, so kilometers squared would be my label, so 78.9 kilometers squared would be my answer. So again, if I'm going to find the area of a triangle where I have the case where I have all three sides, side, 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 I'm going to find my semi-perimeter first, half of A plus B plus C. So half of 11 plus 14 plus 15. So 11 plus 14 plus 15 gives me 40. Half of 40 would give me 20. Then I'm going to find the area by taking the square root of S minus A, S minus B, and S minus C. So I'm going to do the square root of 20, 20 minus 11, 20 minus 14, and 20 minus 15. So this one, since my subtraction's a little easier than with the decimals, I could just go ahead and subtract. 20 minus 11 would be 9, 20 minus 14 is 6, 20 minus 15 is 5. So I'm going to take 20 times 9 times 6 times 5. I get the square root of 5,400. So again, I could either just type in square root of 5,400 or square root of my answer. And so I should end up with 73.4846, rounding to the nearest tenth, 73.5, my label, miles squared, since I'm doing an area. So 73.5 miles squared would be the area of that triangle. And the last one, again, finding the area of my triangle when I have side, side, side. First finding my semi-perimeter, half of 8 plus, I'm going to do it in order, 6 plus 8 plus 12, not that it matters, just so you have all three of them. Half of 6 plus 8 plus 12. So 6 plus 8 plus 12 would give me 26. Half of 26 would be 13. So then using my formula for area, I'm going to take S, which is 13, S minus A, so 13 minus 6, then 13 minus 8, and then 13 minus 12. Again, those don't have to be in order, just so you have all three of them. So 13 minus 6 would be 7, 13 minus 8 would be 5, 13 minus 12 would be 1. So I am going to take 13 times 7 times 5. I don't really need to do times 1, but I could, and I would get 455. Square root of 455. So square root of 455 would give me 21.33072. Rounding that to the nearest tenth, 21.3, my label, yards squared. And that is the end of homework day 33.